All right, welcome again. I'm hammering through the curve section of the nodes in Grasshopper for Rhino. We've gone over and done in Grasshopper for Rhino the ABCs, 1, 2, 3s, the params, math, sets, vectors, and into the curves. We've done the primitives, the splines, the division, and we're into analysis. I've got to do this while it's fresh in my mind. Let's jump into it. Here it is as just evidence of the scripts as I'm bringing out. They're not very creative in a sense. They're just what these nodes, how do you have to do to get these nodes up and running? So let's jump on in and see what I did on the first one. Basically, I'm looking at control points and weights. And what I'm going to do is, got everything showing, even though I don't want that. I want to select something. There you go. It just took a little second to slow down for a second. We'll take some of this geometry and we'll put it on hidden. There's so many things open. And basically, let's go in and see what I've got going on here. I basically have interpolated a series of points, played with the knot style, which I'm going to go in farther with later on, the degree, and the knot style being true or false. And you see I can open up the curve and have it stop. But basically, using that curve and pull it into control points, it's going to basically give you back the points that make it up. The weights are going to give you the weight count, which if you hover over here, you'll get a weight count between 0 and actually you get quite a weight count. It'll range quite a bit. Knots are being positioned, and what do I end up doing with it? I take those points and I throw it through another interpolated curve. What comes out is the points and the control points, because I want to see the control points as well. Interpolate the control points around that initial curve. And that starts to become a very interesting geometry and patterns to what you want to do. If you take off your periodic, it completely changes it as well. So there are some very interesting geometries you got to wrap your head around in something as simple as thinking about control points. So you get the points that run along a line, you have the control points on or off of those, the weights associated with those, the knots, and then kinks that actually come into those. Let's just keep going because it is complex to deal with. Let's go back to that original curve that was there, and we'll leave it. Actually, I think I'll close it up. We'll basically do a control polygon on it, and at this point, I've pulled out these points that'll make the polygon because it's taking those control points and making a polygon with them, and then it's showing me those points. So if I go back into the points that are making it up and the interpolation of those points, you're getting a picture of the control points and then the polygon associated with those control points. So you can start to visualize those. Find curve middle is pretty easy, so just jump into your curve, and the middle of the curve's there, and if I take off the periodic, the middle of the curve is right there in the middle of it, which makes total sense. And it doesn't look like it's there, but it is. You just have to follow it from one side to the other. Okay, so we're jumping into arcs now. Build a basic arc. I just changed the size and scale of it a little bit. There it is. Now what I can do is deconstruct that arc. So you're left with the original, and you're able to see the plane, which is associated with it, and then you can check out in the panel tools what your range of your angles on it is, all the way through to the radius, which is basically what you inputted. It's a nice little tool here. I left it in degrees over here, and then it put it into radians over here. So 160 degrees, you go into radians, so you can do that, kind of see the relationship. Otherwise, you'd have to type in pi here and then type in a number, and then you'd see it come out. Or you can convert this over to degrees. Maybe. No, not from that end, not as an output. All right, so we've got a rectangle also. We want to just deconstruct that rectangle. It's going to give you the same thing, the plane. It's going to give you the domain that comes out of that as a number, and it'll give you a y interval domain, which is basically set to your, pretty simple, it's just set to your sliders. So you see the domain changes as in numbers and data as you change that. Interpolating a few points, I actually just have 2 points interpolated just to show start and finish, and there they are, start and finish. I use that all the time, endpoints. Another one that's nice is polygon, so I have a line here that I've drawn and made this very awkward little polyline. It will show me the center of that polyline. It will show me the center of the, first thing is the vertices. The second one is the edges and the center of the area centroid of the shape. And they don't always line up to what they are, and sometimes you don't even get one. Obviously, the center of that one's open curve. So let's take a closed curve and put that in, see what happens. Yeah, we start to get a center to that, and they all come pretty close to one another. But there are subtleties and differences of that, and those are helpful for finding point normals and surface normals and things like that. Here's closed, so I'm going to grab that first curve, and I'm basically going to ask if it's closed, false. Is it periodic? False. And if I switch over to the other curve, which I had here, it's going to say, well, it's true, it's closed, but it's still periodic, false. Curvature is pretty nice. Here's an awesome curve. And I really like this tool because it builds pretty awesome geometry to make walls and growth systems out of, and you have control over that by the density. And you see as I change the density of how many lines are within that. And you have to set this between about 100 and 110, otherwise it blasts out of this world, man. It's like, you keep going outside of that range that scale is set at like 5% increase, you're going to have like that thing totally blow up on you, which is kind of wild. Otherwise, I populated a geometry, brought it down to 12 count, and I'm finding curve closest point. So I'm actually using this curve to find the closest points that are associated with this, and when I look at it, there's where they are. And they all kind of, the curve's closest points to all those points finds itself here, there, and there. And you can look at those points, the distance from those points in the parameter along that curve as well. Here we go. We start with a bunch of spheres. I thought that would be interesting. Basically pull that into those curves and say, okay, position those. Where are the curve nearest objects? And not only does it tell me the nearest objects to that curve, it tells me the points of where they are, the point B of where it is, and then it goes so far as to show me the index number of which sphere in that index number is the closest one. So it's kind of something interesting. Curve nearest object. I haven't been using that, but I'm going to use it in my geometries around other curves. If you learn to work in curves, you're going to have a much easier time building awesome landscapes and cityscapes and architectural things, because then you bring them up later into geometries and surfaces. But you have to understand your stuff by point, vector, line, math, and then you can run a pretty good script, at least in Grasshopper, in my opinion. I've gone on to Houdini. I've looked at it. It's a whole other vexing operation of getting into scripting, and definitely this pushes you there through the Python node. But I think I have in rotation wanting to go from learning Rhino, going back to Rhino, going into Grasshopper, going into Houdini, and then into Python, and then I circled right back around to Grasshopper again. Anyway, so we've got a couple of points. We've got a curve here, and we're basically saying there's curve A, and I think curve B is this one, so I generated two. And they're not coplanars, so they're kind of interesting to play with. And basically, I've taken and reparameterized them. You're going to find me reparameterizing everything here. I'm finding the distance between them and then the points between them. So point A between them. I'm not sure why I don't have this on here. There's your point on this curve, I believe. And then you'll find the point on this curve as well. And that's where they end up finding the closest proximity of these two. So there's the one, and if I actually grab this, and I'm not sure why I took it off. Oops. Let me go back a second. Let me just copy that, cut and paste that, and take curve B. You'll see those 2 points while they're on the curve and the distance. So what's nice of that, those two, is you could always grab a little curve tool, very simple line, just to visualize. Always be visualizing through line. Don't worry about solids. And there you have that little line that joins this curve, and there it is between it. So not too hard to figure out. Hard to see, but there it is. Okay, so curve side is pretty nice. You can grab this curve. Sorry, forget that curve. Let's grab this curve and basically check which point we used. I actually grabbed all these points. And I said, out of all these points, which ones on that curve are in point... sorry, we're back on the curve left side, which are on the left side, and it'll say true, true, false, 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 and this one will say false, false, true, 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 and they'll go opposite each other, left and right. But you can always just have this number to tell you right or left side by 0, I think, if it's on it, and yeah, 0 if it's coincident, and -1 if it's on the left side, or vice versa. Discontinuity is pretty interesting, taking that curve and finding out on it at what level of discontinuity, which if you change the level of this is interesting, continuity of C1, C2, and C infinite, you end up producing some interesting points, and I'm just going to show you this on this curve, that if I start to play with reparameterizing, it's going to show me where those points are. I only get 2 points at the ends when I'm at proximity C1, and I'll just shrink that. And actually, I don't think I get anything at C. I get it at C2. I get those 2 points as well, and then at 3 I get 4 points, and they'll show me where on T from 0 to 1 where those points are. Highest point's pretty cool, so you can grab a curve and it'll show you the highest and lowest point on that curve. Very nice, which is great for all types of geometry, drawing lines between them as well. So you can take that curve, find the highest points of them, and there I think then I would grab another line tool and just visualizing the distance in those. And this is great for using as remapping tools and finding distances. It's something I thought about using. Planar is pretty cool. You grab it and it says, is it coplanar? No. Is it planar? No. Where's the plane? There it is associated there. And then where is the deviation between that curve? Planar to give you a number, give you data for the deviation. All right, so let's keep going. Let's grab this curve, the same awkward little funky curve, and let's check for reparametizing, finding out curvature points. And I love this tool because if you set this right, it really draws and visualizes for you as a parameter. Once reparametized, you'll see all these things are reparametized all the way through the end, so I can actually get in there. And this is a wonderful tool for start building this circle that goes to the outside, small, comes around, traces the inside, goes to the inside, and you're really finding out where exactly the curvature exists within that point. And this one will give you a look circle at t, and this one will give you a vector at t, so you end up with different data. Curve frames, pretty awesome. Same thing. Let's grab the curve and his curve, and then we're reparametizing. We have a nice plane at any point along that curve and what direction it's going in 3 dimensions. You get some really cool angles to put geometry on. Derivatives are nuts because if you keep your derivatives like along that curve, if I can keep it here, the derivative isn't going to be bad with 1. It's going to actually be located there. But watch how the scale goes crazy. When you start dealing in a derivative 1 as a point, there it is. It derives, it moves that far away from the curve. When you get into the second derivative, you're like, where did it go? And now you're way down here chasing it. You get in the third derivative, and I shouldn't have done that. Get into that third primitive, and that's like, where did that one go off to? I have to chase that somewhere. I'm sure it's way off this field. I can find the this vector, but I start to get lost in the data when I start dealing in derivatives. Evaluate curve's pretty good. Get back in. I think I'll just drag this curve down here so I don't have to jump up and down so much. Evaluate curve's going to give you points along that curve at that parameter. And so the parameter is going to go from 0 to 1, so I can follow that curve around wherever I want that point to be. And it'll show me that point on it. It'll show me a tangent point over here, and I like to draw a line between that. So that's kind of pretty cool to control the geometry to the tangent as that moves. And the bottom end of that tangent actually moves around quite a bit and reflecting that curve. Pretty interesting. And it gives you a data for the angle, which stays at 0 in this case. Horizontal frames are pretty cool. So you're going to pop on the horizontal frame at any point along that parameter. Perpendicular plane, same thing. It's going to pop on a perpendicular flame anywhere along that, so you don't have to end up building stuff. And then a point on curve, which I just love using all the time. It's just to have a point on curve. I use that all the time for geometries. Let's keep going. We're at 12 minutes. I don't think we're going to get through this. Oh, no, we're not. Better just take a break, and we'll start off with torsion afterwards and do a second video for this. I didn't think I'd get through it, and then we're going to go hard into curves, utilities, and finish up curves with all of these things. Then we start to have a little more deeper fun, larger scripts as we get into the surfaces, and we'll start that with primitives. And that will start to be where most people think about modeling and 3D modeling, but you can see we've already covered all the params, all the maths, the sets, the vectors, all the curves, before we even get into those surface tools to transform and do things with them. This is as deep as you want to go, and then actually you can even go deeper, like I said, with the math scripts, and then you can definitely get into coding, which I've seen people do in C, Sharp, and Python for this, which just blows me away. All right, keep going.